In this lecture series video of electric circuit analysis, today's DT-based delivery is about Thevenin's theorem. So, if you are an engineer, you are assigned with the task of powering a sensor. So, we have to find out the value of voltage and current. So, it is difficult to analyze the total entire circuit in a system. So, by using the Thevenin's theorem, it is simplified method to know the voltage and current value. So by the steps we are following in the Thevenin's theorem, we have to remove the load resistance and short circuiting and open circuiting the voltage source and current sources. By this method, we are easily get the value of voltage and current. So introduction about Thevenin's theorem and steps of Thevenin's theorem.
Complex ECA circuits make it hard to calculate load current directly. So now the question becomes, how can we simplify the network? So and now the components are fuel complex circuit on screen, empathize the load resistance. Key points: replace network with equivalent resistance.
So by solving the steps, so firstly we have to remove the load and then form a loop. So finding out the loops I1, I2, I3, we are applying the KVL and we get the 3 or 2 based on the loops, we can get the I values. So by that we are forming the equivalent circuit where it consists of a current source or voltage source, one Thevenin's Thevenin and then R Thevenin. So these are all the step-by-step method of Thevenin's theorem. So any other?
Brainstorming solutions. One way is to remove the load and calculate open circuit voltage, that is removed. Next, deactivate all independent sources to find the equivalent resistance seen by load. Combining these, we replace the whole network with a single voltage source in a series with their system. Components. Stepwise animation. Original network remove load, measure voltage, deactivate source, calculate R to place network with V and R in series. Overlay text. V is equal to open circuit voltage, R is equal to resistance seen from load terminals.
So we explained about the step-by-step procedure which we have to solve the Thevenin's theorem. So next.
Now apply Thevenin's theorem. Let us apply this to a practical circuit. Suppose we have a network with multiple resistor and a voltage source feeding a load resistor. Remove the load to calculate the V Thevenin and deactivation of source to find the R Thevenin. Replace the network with Thevenin equivalent and connect the load. Now won't start. So the components required are animation which shows the calculation of V Thevenin, deactivation of source to find the R Thevenin and giving Thevenin equivalent. Now connecting the load and the final current calculation is highlighted.
Okay. So now I have a question for you all. So in the procedure, everybody is saying that deactivating the source. How you are deactivating the sources?
That's the current source. We are short circuiting it.
If that is a current source, we have to open circuit it.
If that's a voltage source, we have to
Do short circuit it. So if you are having a resistor which is connected in parallel with the short circuited area, then what we have to do?
we can neglect.
So we have to neglect that resistance value. So if the current source is connected in parallel with the voltage source, so current division rule we have to apply. So what is the formula of current division rule? So total current is multiplied with the load resistance divided by sum of the R resistance. So next.
Real-world applications. Engineer use this approach in many scenarios, and first one is sensor circuit. In sensor circuit, it is used to analyze the current without disturbing the network, and in power distribution, it is used to calculate the current through the load resistance, and in the hybrid power system, solar and battery are used to store the power. And then visuals are split screen, sensor circuit, power distribution board, arrow showing load current calculation.
So mainly Thevenin theorem is used only for simplified analysis of sources. So it is difficult to calculate the whole current and power value. So that we are choosing the Thevenin's theorem. Next.
So ma'am, here through a design thinking approach, we have empathized the problem of complex circuits and load analysis and define the problem by short circuiting it and ideated by replacing with an equivalent source by calculating the current Q resistor. So this structured approach makes Thevenin's theorem not just a formula but a practical tool for engineers.
Thevenin's theorem is a powerful simplification method. In design thinking, we learn to approach problems methodically, making complex circuits easy to understand and analyze. Components. Circuit simplified to Thevenin equivalent. Text overlay. Simplify, analyze and apply. Thank you.
Okay. So by applying all these steps and activating, deactivating the source components, finally we have to draw the equivalent circuit. So anybody of you know what are all the things which are present in the equivalent circuit?
Low resistor.
So load resistor, that means load resistor, okay, RL, source, and then
Resistors.
Thevenin's resistance, R Thevenin. So these are all the things which are present in an equivalent circuit.